Okay, welcome back. Like always, make sure you have paper and pencil and space to take your notes. We have 3 theorems we're going to go through this time, and they can be a little bit tricky, so we'll try and show you a few tricks to make it a little bit easier for you. So make sure you write the examples down today. The first theorem we're going to look at, theorem 9.1, is if we draw an altitude from the hypotenuse, or drawn to the hypotenuse of a right triangle, then the triangles formed are similar to the original triangles and each other. So we have a right triangle right here, and then if we draw in an altitude, that's also going to be at a right angle. And so we have 3 triangles that were formed. We have a small one here, a medium-sized one, and then we have the original large triangle. And we'll look at that a little bit more in a second, but right now just get this theorem down that we have similar triangles. And you can go ahead and get this similarity statement down that is here at the bottom. So make sure you write this part down. Okay, second theorem has to do with that same right triangle. If we draw that altitude in, then we have a theorem that says this: the length of the altitude is the geometric mean of the lengths of the 2 segments. So really the part that I just highlighted is what you need to get into your notes. So as long as we have a right triangle with an altitude. Theorem 9.3, same right triangle, same altitude, and if we have that, then the length of each leg is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that's adjacent to the leg. So that can all seem very confusing, but what we're going to look at is the actual similar triangles and make sure that we can write those ratios. And if you can write the ratios, you can find any missing piece. So right now we're going to look at another part, or another diagram. So we have our similar triangle here, and we have the altitude drawn, labeled H. We have sides A, B, and C of a right triangle. So we're going to look at those similar triangles to make sure you understand that. So you can see the little triangle that's in there, the medium, and the large. And all 3 of these triangles are similar, which means their sides are all in proportion. They all have the same scale factor, and their angles have corresponding angles that are congruent. Okay, so if we were going to mark these diagrams, we would know that this angle here is congruent to this angle here, is congruent to this angle here. And then you can see we have a ratio over here. We have R over H equals something over S. So what we need to do is find a place where R and H match up. So let's say we pick this R and this H. So we have a short side over a long side, and then it's something over S. So I want short over long again, because I had short over long for R over H. So the only place S is alongside is right here, which means this would be our numerator. So if we go ahead and say H squared equals RS, that means that H is the geometric mean between this R and this S. So that's where I believe our second theorem comes from. Okay, so we'll go back to the slideshow now. All right, so let's look at an example. You can see over here that I've labeled L long leg, S short leg, and capital H hypotenuse. So I'm going to go through and I'm going to label those three pieces for all three triangles. So if I'm looking at the large ABC triangle, the AB side is the long leg. The BC side, because this is our right angle up here, so BC is our short leg. And down here on the bottom from A to C is the hypotenuse. So if we were to identify the similar triangles, we have triangle ABC is similar to, and now we'll go ahead and label the medium triangle. In the medium triangle, which is here, here, and here, this side right here is the hypotenuse. This side right here on the medium is the short leg, and this is the long leg. Here's our right angle from the altitude. Okay, so now I can say that angle ABC is similar to triangle, and we want to match up hypotenuse and then the leg and the short side again. So here on side AB, that was the long leg. So my long leg for this one is here, so that's AD. And then I went to BC. BC on the red triangle was the short leg. So my short leg here is DB. So now I know I have those matched up the right way with the proportional sides corresponding. So I have one more to label. We'll go ahead and do this one in black. And that's the little one over here. So here's the long leg, here's the short, and here's the hypotenuse. So I need to label it in the same direction. I started with the long leg on the other two, so I'm going to start with the long leg B to D. And then I have the short leg. Before I went B to C, so my short leg is D to C. So you're just matching up. If you just pay attention to which are the short legs and which are the long legs in each triangle, you can match them up and write a similarity statement. Okay, so now we're going to answer question B, and that's to find H. Okay, so I'm going to erase some of this so it's not so messy. And we need to find H. So if I look at H, I have H and I have 7.8. Those are both pieces of the small triangle. So I can go ahead and put those together. So if I'm just looking at the small triangle, I have the long leg over the hypotenuse. So I want to try and find a ratio that I can do that same thing, put the long leg over the hypotenuse again. Well, I have this 14.6 here. That's a hypotenuse of a different triangle. And the 12.3 is the long leg of the same triangle as 14.6. So those are parts of the same triangle, L over H, so I can go ahead and put those together. So if I had L over H before, I'm going to put 12.3 over 14.6. And at that point, I just have to go ahead and cross multiply. So I would get 14.6H, and that equals 95.94. And if we go ahead and divide, H would equal 6.57. Now that is not the only way to set up the ratio, that is just one way. And notice I put this out to the side so I could keep straight what I needed to match up to make sure I did it the same for both ratios. That's all you need to do. Let's look at another example. All right, we're going to do kind of the same thing. We want to find the value of each variable. So this is a right triangle. and this is an altitude. So we're working with that same theorem. I need to find y, so I'm going to start with that. And I'm going to put it over an adjacent side. So I'm going to say y over 5. So if I use y over 5, if I look at just this little triangle right here, y is a hypotenuse and 5 is a short leg. So what I had done was say h over s. So I need to find another h over s relationship in the numbers that I have. So I look here, I have the 5 and the 10. If I look at just this triangle, that's a long leg, and I didn't use that. But if I look at the big triangle, right here, this is a hypotenuse. So I can add those together and get 15. And now I need the short leg. So do I have the short leg of this triangle? And that would be y. Since it's not a new variable, it's a variable that I'm already using, I can go ahead and use it again. And we can easily solve this. So if I cross multiply, I get y squared is equal to 75. And then I simplify the radicals just like we did last class period. So I have y equals the square root of 75. Break that down, and I get 25 and 3. So 5 times the square root of 3. So that is your value of y. Okay, let's try it again on part B. Again, we have an altitude drawn in. We have a right triangle. Has to be the case if this is going to work. So we want to set up our ratios. Again, I'm looking for x. So I'm going to start with x over 6. Kind of hard to tell if these are short sides or long sides, but I'm just going to guess. And I'm going to say this is the long side of this triangle. And this is the short side. So we have long over short. Okay, so if I look for another triangle, I need another long over short relationship, and this is the only side I have. So I can go ahead and use this medium triangle, and I want to go long over short again. Well, this time, if this was a long for this triangle, it's a short for this triangle. Okay, it's never the long side for both. It has to be opposite. So now I can go long over short again, so I would go 10 over x. So you can see we're getting, as we did on the last one, the geometric mean of these two numbers. So we have x squared equals 60. X equals the square root of 60. And the biggest perfect square that I found that would go into it is 4. So we have 4 times the square root of 15. Notice they're both still under the radical. Then I can take the square root of 4, and I get 2 square root of 15. So that's your value of x. All right, these are kind of tough, so let's do one more example. We're going to go ahead and write the similarity statement. So we're going to start out, answer question 1. We have triangle ABC is similar to triangle ADB is similar to triangle BDC. Okay. Go ahead and study that and make sure you understand where all of that came from. Again, we have our right angles in here, so we want to solve for y this time, and that's this side. So let's set up a proportion. I'm going to take y over 18. That's the side that it's closest to. So if I look at the y in the 18, if I'm looking at this little triangle here, the medium-sized triangle, that's the hypotenuse over, we'll say it's the long leg. Okay, so now I want to do the same thing. I want hypotenuse over long again. I'm going to look at the whole triangle. So this big outside triangle, and I want hypotenuse over leg again. So this hypotenuse is 23. So I'm going to put 23 over the long leg of the red triangle is y. So again, I have y squared equals 23 times 18, which is 414. Oh, take that out of there. So we have square root of 414. And I can break that down to 9 and 46. So that equals, kind of ran out of room, 3 times the square root of 46. Okay, let's look at B. Again, similarity statement. So I have triangle EFG is similar to triangle EHF, is similar to triangle FHG. And you can go ahead and kind of study that and make sure you know why those sides match up the way they do. And now we'll go ahead and set up our proportion. So we're trying to find x, so I'm going to go x over 24 equals 14 over x. And if we look at that, x over 24, x is a short side, long side. And if I go over to the other triangle, and I look at the right side triangle, and I would be going short side, long side. So we go ahead and cross multiply. So x squared is equal to 336. X equals the square root of 336, which is square root of 16 times the square root of 21. You might ask how I knew that, and I will be honest, I did trial and error until I found a perfect square that would divide into 336. So I just kept trying. I tried 9, I tried 4, and eventually when I tried 16, it worked, came out 16 times 21, so that ends up being 4 times the square root of 21. All right, last thing. This is your extra credit problem for this video. Make sure you copy down the diagram and go through all of these choices and decide which ones are true and which ones are not true. So this is what you're looking for. And then explain why you picked the ones you did. Make sure you explain. That'll be part of getting credit for the extra credit. And that's it for this video. Make sure you go back and rewatch or just pause on any parts that you missed and make sure you study these notes. It is a little bit difficult, so it would help if you went back maybe and watched some of it again. Thanks a lot.